Actually, out of curiosity, have any of you ever been deep sea fishing or caught anything awesome? I've gone salmon fishing before, and I've caught like big salmon, but it wasn't like that. This felt like when I first had it, like I was already in like this chair, but I wasn't strapped in, and the fishing pole's like into this like mount thing that holds it, and you're just holding on to it like this, and all of a sudden the pole I thought it was going to snap in half. So then I scream, and then the first mate guy screams. Everybody's screaming, and the captain, he's up like on the second deck. It's like a two-deck ship thing, and he just guns the engine to set the hook. Like a human being wasn't capable of setting the hook. So he guns the engine to set the hook, and I'm holding on to this thing, and like it feels like the rod is going to snap in half. And so then he starts strapping me in, and he's telling me to just reel. It felt like there was like, I don't know, a medium, like a Honda Civic or an Accord, something like that I was dragging in from the water. Like something big. And then as you were doing it, like you were in the middle of reeling, all of a sudden it would like pull real hard and like hurt your wrist, and it was terrible. And like I couldn't even walk afterwards because I had like my feet up on the thing, like trying to like not fly into the water until they got me strapped in. And all my legs were shaking, partly from exhaustion and partly from adrenaline, I think. And I didn't even get bit by the shark. That would have been better if I would have had a scar. I did get bit by something when I went in the ocean, though. I don't know what it was. Maybe like a jellyfish stinger or something like that. But I was out in the ocean. My wife was like taking pictures of me from a nice safe distance. She doesn't go in the water. She went into the sand once and then decided that was it. No more sand. But something bit my finger, and I'm like looking at it out there. And so she's got a bunch of pictures of me like examining my hand because I almost caught a second shark. All right, so I want to kind of revisit an old slide. I'm going to try something here for a couple of weeks, and we're going to bounce back and forth between something. I was looking at some other technologies we could possibly explore the second half of the semester that would be in line with the goals of this course. And I think it would be, in order to get us to that point, we need to talk about kind of a second side of programming languages here. So when we looked at these languages back here, this was probably first couple weeks of class or something like that, and we were saying kind of everything branches off this C programming language. So this is back here in the 1970s, let's say. 70s is fair enough. And then we had the Apple language and the Microsoft language, so this is the object-oriented version of these guys. Then we had some of the newer languages, Java, C#. Office, we also had Objective-C, so this is kind of the iPhone, Macintosh side of things. This is the C, this is the cross-platform thing. This is the Windows-only thing. So we'll call this the PC line, really, where Java should be somewhere in the middle, but whatever, this is fair enough. Okay, but now what I want to do is I want to come down here. And I want to talk about the web. Because really where we're going here is there's this, within computer science, there's all these buzzwords, especially within languages, and they all mean the same thing. So how many of you have heard of PHP? Okay, how many of you have heard of Python? How many of you have heard of Ruby, specifically on Rails? Okay, anybody know what Ruby on Rails means? Just a fun thing to say, Ruby on Rails. How many of you have heard of Node.js? Well, that's a new kid on the block. So we're going to talk about several of those things and really talk about them in terms of the web. What is the web? When we say the web, what do we mean? Okay. No. Glad you said that, though. A lot of us think about the web as the internet, right? What when we think of something being delivered via web or a website, it's going to be delivered to us through a web browser, right? Is that all the internet is? What other applications, what other internet-based applications do we use? Email, sure. Now, a lot of us anymore read our email through a web page, don't we? They're delivering, if you're a Gmail user, for example, you might go to gmail.com and you experience the entire email experience within a web browser. It's a web application delivered to you, right? And then we also configure, if you have your smartphone, you might have your email configured on your smartphone, so you're using an email client that talks to the internet magically, right? And pulls your email down somehow. All right, so email's a web application or an internet application. What else?
Games.
Okay, certainly games now. I mean, you can't even buy a game anymore that isn't online aware, right? Or if you do, it's considered a stupid game. All of us have. If you're a gamer, you have problems sometimes on campus where ports are closed because you can't play your game, right? You can't communicate with the rest of the world. Okay, so we can certainly say that our modern video games utilize the internet for, multiplayer stuff. What else?
App stores.
Certainly app stores. Whether that is on the mobile devices or Steam. Steam would be an app store, right? Okay. Or Battle.net, the Blizzard version of Steam, right? Kind of, so you're not a Blizzard guy. You hate Blizzard? Why do you hate Blizzard?
Steam's is far better. Origin's even worse. Origins.
Their bank account would probably disagree with that. So really, Steam is more all-inclusive. Where Blizzard, you got to play Blizzard games. That's what you hate about it, right?
All right. Steam can give away $10 million from a free game.
They can do what?
Give away $10 million in prizes to a free game.
Well, so could Blizzard. They just choose not to. It's different. Blizzard's like the Apple of video game makers. They have a huge cash cow of money. They don't give it to anybody. Just keep collecting it. And then they find other people who make games, and they decide, oh, well, let's make a game that might be very good. What's the new one? The League of Legends clone.
Dota.
No, the one from Blizzard.
Oh, from Blizzard.
Yeah. Well, in any case, I played the.
Steam.
Huh?
Dota's Valve. Steam.
Yeah, I've played on. I played the beta of it. It's pretty good. I think it'll certainly compete. Probably supplant, I think, some of the other ones, League of Legends, and I think League of Legends is already kind of superior to Dota, at least in a lot of people's eyes. But in any case, I think it'll supplant it, not necessarily because it's the better game, but because Blizzard has the resources to throw behind it, to throw up giant worldwide tournaments and, whatever. So, yeah, it's good we have Blizzard. Yeah. Heroes of the Storm, that's it. It's actually a pretty decent game. I'm a lot better at it than I am at League of Legends. League of Legends, there's too much stuff going on. I can't handle all that stuff. I need,
Dota.
huh? Yeah, I heard Dota's worse.
No,
I heard there's
complicated.
huh?
It's more complicated.
That's what I mean. Yeah.
Graphics.
If I can't handle League of Legends, how am I going to handle Dota?
You figure it out.
I need what are those? They're called MOBAs. Is that the type of game it is? Massively online. Battle Arena, is that it? Yeah, I need like that, the Hello Kitty version of that. That's what I need. Okay, so we have video games, they're internet stuff. None of us in here have ever used a BitTorrent client, I'm sure, right? MuTorrent or anything else for stealing illegal music or movies? Illegal what? No, not us. Okay, so any sort of application you launch on your computer or your phone, whatever, that requires an internet connection in order to work would be considered an internet client or an internet program, right? It's more than just web browsers. Okay, now we go look at the history of this a little bit, though. How long have web browsers been around? Since the beginning of the internet, fair enough. Okay, when was that? When was the beginning of the internet? What year-ish? Is it the 70s? The 2000s?
Well, in what regards? Internet available or internet used?
You choose. Let's answer the question. First web browser. Give me the time, rough time period of the first web browser. Was it during your lifetime?
92.
Is that what Wikipedia said?
Yeah.
Is it Mosaic? Is that the name of the browser, Mosaic? Or you didn't get that far?
Didn't get that far.
So probably right around 95 or so is when people really started using the internet like it was a thing, where people had dial-up modems. It was mostly in schools and stuff like that. How many of you were not alive in 95? Yes, that's so. Most of you were born when the internet was born. is that about right? So a lot of us have 95, 96 birthdays. That can't be right, is it? 96? Okay. So early days of the internet, we had other applications that we don't have anymore. One of them was called Gopher. Okay, Gopher was like search engines before search engines existed. Because we didn't have the Google back then. In the early days, you had a couple of wannabe search engines, but the internet was only this big, not it's huge like it is now. But in any case, the web was born. Early web pages, which people just called home pages, right? We just called them home pages. They might have had one or two pictures on them and a lot of text. And part of the reason for that was, our internet connections were slow. We complain when we were only getting, 10K a second now, right? Okay, 10K a second, people used to pay thousands of dollars a month for a 10K a second internet connection. Something we think is just garbage today. Like, no way I can steal this movie in a reasonable amount of time, right? It's just not reasonable, okay? Especially with Concordia's internet connection, it's going to take me 5 or 6 hours to get this first run movie. And I am not going to $5 Tuesdays. Is $5 Tuesdays at the theater down the street? You factor in gas money and time and the fact that you don't have to break the law. And you throw all those things in there. It's just not an option, is what I'm saying. So in any case, internet was pretty slow. And we had some other technologies that were also holding us back. This is the early days of the web. And so besides our internet connections being slow, the content we were trying to deliver was too big. Most of it was images. In the early days of the internet, we were delivering images in a format called bitmap, BMP. So if you take a photograph of something on the internet today, and if the PNG or the JPEG you pull off the internet today is, let's say it's 100 kilobytes, something like that, that same picture as a bitmap would have been several megabytes. So a bitmap is a uncompressed image. Well, back then, in the early days of the internet, we had no reason to compress images because we weren't sending them over slow internet connections. So bitmaps we were sending them over internet connections, so the images were too big. You might go to a web page and start loading the page, and you'd actually see the picture come in one line at a time. And like 3, 4, 5, 10 minutes later, this web page with one picture and a wall of text would show up. And the one picture was a really tiny picture to make it small enough that it would be reasonable to download on the web page. Okay? And actually, even before we had the graphical internet, you had text-based web browsers. Text-based web browsers, where you didn't even get the pictures. You just got the text. And you go to your so one of the popular text-based web browsers back then was a tool called Lynx, Lynx. And, we ran from the command line. Then you also had these bulletin board systems you could remote into. You would dial into the one that was near me was a thing called PrairieNet, which the University of Illinois in Urbana-Champaign ran. And, so PrairieNet had some online game stuff and But you all connected to a central thing, and you play the game on there, and you could do your email on there, and all this other stuff on there. Another popular one was Prodigy and AOL. So AOL came later when graphics, existed. Prodigy was in the early days when there weren't necessarily graphics. But in any case, those were the primitive days of the web. If we look at a web page today compared to a web page 10 years ago, what differences do we see? Has the web evolved? Is it a lot different now than it was before? Every year, does it get more and more complex? Are they delivering stuff that wasn't even possible not that long ago? So they're really stretching what can be delivered through a web page, right? And this all comes down to the technologies that keep getting invented for delivering stuff through the web. And there's all sorts of them. We've heard of Flash and Silverlight, and Silverlight's the Microsoft competitor with Flash. And then you have HTML5, which is all those guys are bad, so we have this new guy, and we'll talk about some of those. And then we have all these underlying technologies. Well, in the early days of the web, you had pages that were just static. You go there for information. There was no, almost like a Wikipedia type thing. Although Wikipedia is not really static because you can edit pages and stuff like that. But in terms of when you search for something, Wikipedia just presents data on the screen, right? So let's call that a static page. Call that static. All right. Well, to just present data, not really a hard problem to solve. What's the job of a web browser? The job of a web browser is to interpret HTML and also JavaScript, which we'll talk about, and turn it into pretty pictures. Okay, that's what a web browser does. But sometimes when we're using a web page, we want to we do something. We log in, right? We put our username and password in and hit submit, and it magically goes somewhere. That requires an internet connection, right? For us to log into our Amazon account or something like that. And then we also have games on there. So if we're playing Angry Birds in our web browser, we're interacting with our mouse and it's playing like it's a video game on a computer or on a smartphone, something like that. Kind of the same thing. So our web browsers are delivering content that they never were meant to deliver, or never, we didn't imagine they could deliver years ago, even just several years ago. And we see the evolution of how this has happened. Okay, so we go back to this slide here. We have this C programming language. This predated the web by a lot. So did Objective-C and C++. Really, Java came out kind of at the same time as the web was sort of kind of coming out. Mid-90s, kind of right in there. Now, understand that the internet was initially a project from a bunch of universities just to send data back and forth to each other. A way to communicate with each other, almost like telephone for data. Okay? Well, so Java came out, and so whatever. So you had people writing software for computers using Java at the time, and people were already writing applications using these other languages for computers. But now you have a whole nother layer on a computer. So when we think about the web, we're really thinking about delivering content to a single application that's running on a computer. So we're adding another layer there. So rather than writing applications directly for the computer, they created a web browser, and the web browser was the application that then played content, like our web pages, and now it plays video games and crap like that as well. All right, so this was something new. Before that, we had our Java applications, our C++ applications, our Objective-C applications running natively on the computer. All right, fair enough. Well, now when the web comes out, and even in the early days of the web, we can imagine we want to have some dynamic content. That is, we want to have something like a web form that asks us for our username and password. We hit submit, and something processes it. There's got to be a computer program somewhere that deals with that. Okay? So, we have to look at the languages that supported that. When the web first came out, we had these things called web servers. So a web server, an example of it was a tool called Apache. Apache is a web server. It served web pages, HTML documents. Okay, so it served web pages. So your web browser would request a web page from a web server, and the web server would send it back. This required the internet. So this communication here required a two-way communication. Web browser would request. Web server would respond. Okay, and this is the internet here in the middle. So we're leveraging the internet to do this kind of stuff. Right, well, what was the nature of this web server? Well, this guy was a piece of software running on a computer as well. That's fine. So Apache was a computer program running on a computer. And its job was to receive requests from web browsers and send responses back. Just like the web browser was a program that ran on a computer. This would be considered client-side. So this is the client side of things. And this would be considered the server side of things. Make sense? So the stuff that's happening on our computer that we see as the users is client side. The stuff that's happening on the server that the programmers are probably writing is the server side. Okay? So these are the two sides of the web. Really, if you think about this, this is the predecessor to cloud computing, where stuff happens up in the cloud somewhere. Cloud's just a fancy name of saying a server that isn't in my living room. Okay? And we view it through an application that runs on our computer. Just like we view apps on our smartphone, something like that. Well, back then, in the early days of this computer, this server, if you will, so we can say this guy's a server. Most of these were Unix computers. So this is probably a Unix server. Windows jumped on pretty quick. They had a web server called IIS, Internet Information Server. Those are the two big ones today, even Apache and IIS. Doesn't matter. We'll just use this as our example. Okay, so Apache was a program that was meant to serve web pages and was running on a server, running on a computer that was probably running the Unix operating system and might be doing other things. So for instance, at a university like Concordia, that same server that was running the web server, the Concordia's web page back in the early days of the internet, let's say, was probably also running their email server, which also was new. People hadn't been using it for a real long time, so you didn't have millions and millions of emails and spam and all that stuff coming in every single day. It was new. People hadn't started taking advantage of it yet. Okay, so you might have had one machine doing all this stuff. More modernly, you might have 2 or 3 or 4 servers in a place like Concordia. One server might be our web server, another server might be for email, another one might be for like Angel and Blackboard, that kind of stuff. So, we're delivering various internet services through different machines just because they have, some horsepower requirements to deliver it. Okay, but really what we had here is we had a server that had been around since for years and years and years. This Unix operating system. When this Unix operating system came out, it had no idea about the web. The web was, hadn't even been considered. Okay, so this guy was not web aware. Apache was a computer program somebody probably wrote in C or C++ to run on this Unix server that could serve web pages. This is just a computer program that somebody wrote, and its job was to take requests and send responses. That was it. Nothing special about it. Okay? Well, so in the early days of the web, when we had web pages that had, go in here real quick. So we might have a web page. Good enough. So we have an HTML page that looked like this, and if I were to run this, let me go ahead and that's very nice. It doesn't give me any of my text. Oh, beautiful. Make it plain text, and we're going to save it. And we're going to save it to our desktop. And we're going to call this guy blah.html. All right, so after all that work, now we have a file on our desktop called blah.html. If I double click on this, it'll open it up in a web browser. And there's my page. So it has a little web form in there, although I put type equals submit. Submit should have been allowed. If I can say username is equal to that. Should be a submit button. That's not the way you do it, but let's just see if we get a button showing up. Doesn't really matter. No, just forget about it for a second. Not a big deal. In any case, we have a web form. And, you know, the idea is you put your username in here, blah, blah, blah. You hit the submit button, and it goes someplace. Okay? Well, when we say go someplace, it's calling a program someplace else. Okay? It's calling a program someplace else that has to process it. Where is that program? That program's going to live up here in that web server. Okay? So when we're on this web page, and the web page is being served from this web server, and this guy's called blah.html, and it shows up on our web browser, and we put in our username and password and hit submit. It's then going to send that information, our username and password, back here to the server to be processed. So there's got to be a program here on the server to be able to handle that. Now, in the early days of the web, we didn't have specific web languages. We didn't have the ability to handle these things. So what we had to do is we had to take existing programming languages that existed on Unix to process these web forms. So what I have here is an example. It's really bugging me. Submit is the type. Action method post. Oh, that's got to be it there. Whatever. Still going to bother me, but I'm just going to keep going. In any case, here in this web form, we've said the action for this should be a program called blah.sh. okay, which is a computer program somewhere. And the .sh, I've done that for historical reasons. This would be a shell script using the sh shell for Unix. And the shell is from, like for instance right here, I'm out at a Unix prompt. This would be the shell, although this is the bash shell that I'm dealing with here. If I say exit there, let's just do sh. Here's the sh shell. So, I could write a program using the sh language and have that be a shell script, and that guy could then process the stuff coming from a web page. But understand that sh existed for years and years and years and years before web ever existed. So we were leveraging a tool to do something that was never meant to solve that problem. So that started giving us the need for newer languages that were kind of internet aware, if you will. Pretty soon after the internet actually became popular, so if we're dealing with server-side languages here for a second, in the early days, we used something called CGI, which is a common gateway interface. And CGI would then be supported by existing shell scripts. SH, Bash didn't actually exist then, SH and CSH. Okay, so shell scripting language that belonged to Unix. Shortly thereafter, the popular language, so let's just say this was the beginning, was a language called Perl. All right, and let me actually just move all of this over. Okay, so the technology that was used was CGI, Common Gateway Interface. That allowed a web browser to call a web server. The server then used this CGI thing to process web forms using a language called Perl. And Perl was not a web language. This was a language that a lot of Unix system administrators were using, and it was just kind of the popular Unix programming language as opposed to using shell scripting languages. All right, so Perl was really, really popular amongst Unix system administrators, but it didn't have web-aware tools in it. So what people started doing is they started building libraries in Perl for handling those types of things. Pretty soon, the internet looked like it was here to stay, became very popular. So what did we have? We had a new language created called PHP. And by the way, PHP is based on C. If you are a C programmer and you look at PHP, it looks very, very similar. So PHP replaced the need for CGI and Perl. PHP brought those two things into one package, and what happened is there was a PHP module for Apache. So rather than Apache having to go through CGI and then calling a Perl script, Apache would just call its PHP module to process a request. So now your web form, instead of going to blah.sh, it would go to blah.php. All right, and this .php thing here is something known as a MIME type. Fancy way of saying it's a PHP document. Okay, and because you're requesting a PHP document, the web server here knows it has to do something extra. You're not just requesting an HTML document, which the web server just throws back at you. Because it's a PHP document, it has to process it in some way. So it's going to pass that to the PHP module. PHP module then does its magic and shoots out the answer. The output of a PHP program, since it was made for web, the output was always HTML. And we'll throw JavaScript in there in a little bit, but let's just say for right now, the output of your PHP program is always HTML. Why? Because the person who's going to be viewing it understands HTML. Your web browser knows HTML and knows how to make it look pretty on the screen. All right? So you're requesting a program to be run. The program runs, spits out the result in HTML. HTML gets sent back to the web browser. The web browser then interprets the HTML and makes it look pretty on the screen. All right? So that was PHP. PHP was designed for the web. Again, this is a server-side language. So PHP would be considered a server-side web language based on the C programming language. Client-side languages We have HTML. And we have JavaScript. Okay, these would be our client-side languages. That is the stuff that our web browser knows how to deal with. Okay, web browser knows how to interpret HTML and make it look pretty on the screen. It also knows how to interpret JavaScript for dynamic stuff to happen on the client side. We'll talk a lot more about this. Okay, good.
Doesn't JavaScript have a lot of viruses in it now, as opposed to HTML?
They're not even the same. They're not even the same thing. I mean, I think what you're getting at here with viruses is JavaScript is something that executes locally. So when I go to a web page and I load a page that has some JavaScript in it, the web browser has to then go and execute that JavaScript code in there. So somebody could embed a virus type thing inside of a web page and take advantage of maybe a security hole in a web browser that allows something bad to happen to your system or something like that. Where HTML is not dynamic. HTML is just static content. There's nothing executable about it. It's a data organization or text organization language. Okay, and we'll see that through some examples, probably next class, but regardless. All right, so these are the two languages, and I use language very loosely with HTML because it actually does not fit my definition of a programming language. If we go back to my definition of a programming language, it's something that mimics the way human beings solve problems. That is, it provides a way to do variables through memory, well, memory through variables, ask questions through conditionals, and then loop, repetition. Okay? HTML doesn't allow any of that. Can't create variables in HTML, can't ask questions, can't create loops. So by that definition, HTML is not a programming language. I might call it a data representation language. JavaScript, though, this guy's a programming language, also based off of C. So that gets back to this guy here, where all these languages came from this top level guy, C. Okay? Even today, the languages that our web browsers natively understand are those two languages, HTML and JavaScript. You can get plugins for Flash and plugins for Silverlight and different things like that, but at the end of the day, natively, every web browser is guaranteed to support these two things. Most of them also support something called VBScript, and that's more for historical purposes. In the early days of the web, there was a competition between client-side scripting languages, JavaScript and VBScript. VBScript lost. So you had a language called VBScript over here. It's a Microsoft thing. VBScript later became something called ASP, and it moved over here to the server side. And now it's called ASP.NET, still on the server side. All right, so it lost the client side war, and now it went over to the server side in a much newer format. And this is the ASP.NET is the PHP for Microsoft, Microsoft-based websites. Not that important for us here. Okay, so everything that your client side knows how to do, it does in terms of HTML and JavaScript. Early days, we used CGI and leveraged an existing program called Perl. Then we came out with a programming language, or existing programming language called Perl. Then we came out with a programming language that was built with the web in mind. That was PHP. And the output of your PHP programs would be HTML and JavaScript. That is, it would be stuff that the web browser knew how to work with. All right? And even today, we can say that PHP is still the most popular server-side language. But over the last couple of years, that's been changing. It's been changing. And that's where we start hearing of some of these other guys. So we hear of Ruby on Rails. Python. Node.js. Okay, and then we start hearing other things over on this side because we just throw buzzwords all over the place, right? We have jQuery. Maybe you've heard of jQuery before. All right, anybody know what jQuery is? It's a cool sounding thing. Prior to jQuery, we had a technology called Ajax. You heard of Ajax? That's fun to say too. Okay. So we had jQuery, we had Ajax. Node.js actually kind of lives between these two. We're going to talk about these in a lot more detail next time. Just kind of showing you where we're going today. Just the real quick answer here. jQuery, Ajax, these guys are just JavaScript libraries. They are things that are written using a language that's been around for 20 years. Okay, so jQuery is a JavaScript library. That is for client-side stuff. Why does jQuery exist? Ajax was its predecessor. It did the stuff before jQuery did, but then they must have decided that Ajax didn't sound cool enough, and they had to come up with jQuery. It sounded cooler. Why does it exist? Anybody know what the purpose of jQuery or Ajax? Why these client-side libraries? Why somebody wrote them in JavaScript? They wrote it in JavaScript so it would run on a web page. In the old days of web pages, when you hit submit, and whenever you dynamically change something on a page, click the link or something like that, what would happen? A brand new page would load, correct? That means it would send a request to a server. The server would then process it, and it would send the response back in HTML and JavaScript. Well, sometimes we want to do things locally on the web browser before sending it up here. So we could do that with JavaScript. That was the early days of that, where we were basically checking to make sure web forms were filled out entirely. You know, if you didn't put your email address in, we're not going to waste our time sending it to the server. But more modernly, these technologies allow pages to refresh portions of the page dynamically without having to reload the entire web page. That's all they are. All these guys are power tools built in terms of an older tool that allows you to have a page change its content without having to reload its entire page. That's it. All right. When we come back on Wednesday, I'm going to talk more about these technologies over here and how we got here. Where we're ultimately going with this is we're ultimately going towards tools that leverage these scripting languages to allow us to do software development for cross-platform type stuff. Okay, and that'll make more sense when we talk about it. But so we are going to look at a little bit of syntax the second 8 weeks. And we're still going to be dealing with game salad to a certain extent as well, but we're going to be bouncing back between the two of them. I'll see everybody on Wednesday.